Hello, and thank you for your interest in Asprova. My name is Lukas Herford and I will guide you through this demonstration. Before we hop into our software, I would like to give you some information about our company. After the demonstration, I will list some of our references, but bear in mind this is just a small excerpt. For a more complete list, please visit our website. I'll give you a little insight into our company. Asprova was founded in 1994 in Japan and is specialized in development of advanced planning and scheduling software. In 2008, the German Asprova AG was founded for the European region. Meanwhile, we are trusted by 3,100 customers worldwide, and we can look back at close to 30 years of APS experience with top leading companies. Asprova is represented worldwide. Besides the headquarters in Tokyo, there are also offices in Washington, Shanghai, Seoul, and Kuala Lumpur. And of course, for the European region, there is Wetzlar. In addition, we have built up a strong international partner network which supports us in the implementation on site. Among others, there are Poland, Czech Republic, Hungary, Spain, etc. Asprova APS is available in 12 languages. Russian and Italian will be edited soon. First, let's talk about Asprova APS. Our APS software can be roughly divided into two areas. One, production scheduling. This is used for short-term sequence planning. We talk around a planning horizon of 2 to 8 weeks. Hereby, a detailed sequence planning can be determined for each resource. Resource can be, for example, raw materials, machine, employees, tools, etc. Furthermore, you can use our APS software for medium and long-term production planning. Hereby, we talk about a planning horizon of 2 to 60 months. Here, your planners can simulate various scenarios and their impact on production. Among other things, there's shift model adjustment, employees, lot sizes, new machines, etc. These two functions are combined in one software. In addition to our highly capable APS software, we offer a software for supply chain planning, Asprova SCP. Here you can use an infinite number of production sites, logistics centers, transportation resources, etc. You may have already read the headline in the beginning, Orchestrated end-to-end planning and scheduling software. But what do we mean by this? Hereby I would like to use a comparison. Imagine a production as an orchestra. If the wind instruments don't play the same beat as the string instruments, there will never be any harmony. The same can be projected onto the production. Good production flow and avoid stagnation, a clock generator, a conductor is needed. In the example on the left, we see a planner who monitors the production from a bird's eye view and sets the pace for all process steps. This is the only way to plan an optimal sequence. You may already know that Japan is one of the countries with by far the highest fixed cost. This forced Japanese companies to really early on focus on 100% on-time delivery, shortest possible lead times, and minimum stocks. Accordingly, they have the highest demands on our APS software. Asprova APS was developed in cooperation with those top lean companies. With Asprova, you're not only getting a highly functional software, but also the know-how about lean planning. In order to plan a production optimally, all restrictions of each process steps must be considered. In Asprova, we are doing this by our standard parameters. 99.9% of all restrictions can be done inside of Asprova and we're not needing any complex programming. But without further ado, let's jump right into the software. This is the integrated master data. We can see finished goods, for example sample part B, and this consists out of one plastic part and one metal part. We can jump into a more graphical view to see the entire value-added chain. On the right side is the finished good assembled part B. Here we have a one-to-one production. More in the middle part, we have the metal part B and plastic part. Those two are remotely close to a make-to-stock production. You can see that we have production lot sizes. The plastic part also consumes one granule as raw material. We can simply close this and are back at the master data. Now let's head from the integrated master data to the order table. Here we can see all the different customer demands. Those orders can come from your ERP system, for example. In this case, order number 73 is asking for assembled part A due on the 8th of August 2021. It requires an amount of 200 and it's delivered to the customer B. Before we start planning all orders, I would like to show you our resource Gantt chart, probably one of the most important tools when working with Asprova. This is our resource Gantt chart. Your planner will have everything in check on a visual basis. All the orders will be planned along the x-axis, or the timeline. On the left-hand side, we can see all the different resources available. For example, exterior warehouses, raw material stocks, different suppliers, all the molding machines grouped together, all the CNC machines and the group as well, the assembly work center and the packaging work center. We can see that we have a capacity of 4 at the assembly work center and a capacity of 2 at the packaging work centers. This means that 4 orders or 2 can be managed at the same time. And at the bottom we can see our customers A and B. To plan all the orders, we can simply click this button at the top or press F5. Around 300 customer demands are planned and assigned according to the resource restrictions. A MRP2 run is happening in the background as well. We can see some hatched orders right here. This indicates that those orders already started or finished. We can double-click right into this, go to Resource and check it. This information can come, example, from your MES system or directly handled in Asprova. Here we can see that already 2,800 are done out of the 4,000 initial quantity. When clicking an order, you can see all the different orders that are connected to it. The connections are represented by the purple lines. Let's check maybe a different order and see where it comes from. Here we can see the sales order 75 and all the different steps it has to go through to fulfill this order. Now we can see all the different links and see which order is consumed to fulfill this order. We can even jump by using double-click in the object browser. This is a really easy way to navigate along the entire value-added chain. In the resource Gantt chart, the orders are placed next to each other. The production is shown as an optimal sequence. To have a more aggregated view, we can see all the customer orders in the packed order Gantt chart. In the packed order Gantt chart, all the orders are sorted by the due date. So we will head up to the top to find the earliest demand. Here we can see the earliest demand is on the 4th of August. This is indicated by the red triangle. Depending on the definition, this means the date is ready to ship, or this is the date the customer expects the item to be there. Now let's check out the order 003. If we open this up, we can see all the manufacturing steps to fulfill this demand. Here we can see that the assembly process takes all the intermediate items from already prior finished orders. Now let's check maybe a different example. For example, 134. Here we can see that the assembly takes some quantities from this manufacturing order and some quantities of the metal part from the prior manufacturing order, as well as some plastic parts which consume stock. The packed order Gantt chart is a great way to have a quick overview and check if maybe some problems are in the production, for example some latenesses, etc. Speaking of lateness, let's check if we find one where we have a lateness. So far so good, and we don't see any lateness. Let me go over here a little bit. This is a great example as well. Here we can see a purchase suggestion by Asprova. This is indicated by the blue bar right here. If we check the entire value-added chain, we can see that for the plastic part F, we consume some granules from the stock and from the purchase order. This means that we don't have enough stock to fulfill all the 4,000 pieces. We can easily see the different stock levels. Let's check out the stock level for the granule Z. We right-click on the purchase suggestions, go to drill down, inventory graph, output item. Here we can see that we don't have enough granule stocks. The inventory graph is a little bit bigger, so we can see it more clearly. Here we can see that the 72 kilograms are not enough to produce 4,000 pieces of plastic part F. Asprova's start time of the production depends on availability of raw materials. Therefore, the production start time of plastic part F corresponds to the production end time or delivery time of the granule C. Okay, let's maybe check different examples again. Zoom out a little bit to have a more comprehensive view of all the orders. And here we can see already one late order. How do I know this? It's because of the production prolongs after the red triangle. And the order is also indicated with the red check mark, and we can see the earliest fulfillment date will be the 28th of September. But why is it a late order? Let's check it out. At the first glance, we can already identify the issue. It's because of the plastic injection molding starting way too late. But why is it like this? It's because we have a delivery time of the raw materials granules X that takes 8 weeks. And this is obviously way too long if we have a customer demand in 6 weeks. Let's visualize this for a moment. We go to the purchase order again, go to drill down, inventory graph. I will make this a little bigger. Here it's clear that we don't have enough materials prior to delivery. Just when we get the new delivery, we can have enough materials to start the production. So how do we countermeasure this? We could try to shorten the lead time. Go to drill down, assign resources, and instead of a delivery time of 8 weeks, we will simulate a delivery time of 5 weeks. Now we will reschedule. Bear in mind this is just a simulation. If a faster delivery time will help us with our demands. We can see in the simulation that a shorter delivery time will help us with our due date. To get back to the initial situation, we can delete our custom delivery time. We can do this because the purchase lead times are saved in the items. Here we can see that we have a standard purchase lead time for the granules X for 8 weeks. Now if you plan again, we are back at the initial situation. Assuming this will be our production plan, there is one question that comes right to my mind. Do we have to produce this metal part B that early? Double check this in the production view. We check the assigned resources and combine this view with the inventory. Here we can see the inventory of metal part B and the corresponding orders. If we move over those orders, we can see that the stock will adjust dynamically. We will switch this over to the start of the production of the assembly line. As we can see, the inventory stock will be lower than before. Of course, we can do this order by order, but this will be quite time consuming. Asprova is working rule-based or based on optimization targets. Our goal is to produce just in time for the assembly line. To have a synchronized end-to-end production plan, we will have to orchestrate every order around the bottleneck process. In this case, this is the assembly line. Therefore, all process steps are indirectly dependent on the assembly line. This optimization goal is represented in the different scheduling logic we prepared for you. We revert every change back to the beginning. Now we head over to our scheduling parameters, go to Simple Scheduling 6 and reschedule. As you can see now, we have a just-in-time production for the assembly line. This is just one small example how to optimize the entire value-added chain to have lower inventory stocks. Of course, there are a lot of different examples. For a more complex prototype that suits your production better, just write us an email. We will get back to you as soon as possible. In the next step, we will head back to the presentation. I hope you enjoyed the small live demonstration and were able to get a good first impression on Asprova. Thanks to our standard parameters, we are able to map a wide variety of different productions. For example, the food industry, the healthcare industry, electronical engineering, automotive supplier, or the textile industry. Of course, this is just a small excerpt. You can visit our website to have a more complete list of our references. At this point, I would like to review the orchestrated end-to-end planning once again. The conductor synchronizes all processes steps. This leads to shortest possible lead times, optimal sequence planning, and low inventories. As already mentioned in the beginning, I would like to emphasize the following. Multiple conductors, orchestra, will never achieve any synchronization, harmony throughout all processes. The asynchrony leads to long lead times and high inventories. This again leads to unnecessary binding of high capital. We are of course at your disposal. Feel free to write us an email or call us directly. You are also welcome to attach your problems into your email and we can discuss those problems in a personal meeting. Thank you for your interest in Asprova and thank you for your attention.